Now let's do some Riemann sums. Before we get to the definition of Riemann sums, let's look at finding the area when we're not taking equal partitions. In this case, I want to take partitions of I squared over n squared. So if my c sub I is I squared over n squared, then my f of c sub I is going to be the square root of I squared over n squared. And this is all positive, so let's just take that as I over n. Let's find delta x of I. That's going to be I squared over n squared minus I minus 1 squared over n squared. So this is my I. So we're going to go back one here. We multiply this out. I squared minus I squared plus 2I minus 1 divided by n squared. So delta x of I becomes 2I minus 1 over n squared. Okay, so now we're going to take the limits as n goes to infinity of summation from I equals 1 to n of FCI, CI, divided times delta x of I. All right, now let's just plug this in. This is the limit, and yes, I know this is a pain, but go and write it down. As n goes to infinity of the summation I equals 1 to n, FCI is I over n, x of I is 2I minus 1 over n cubed. Let's rewrite this as a limit as n goes to infinity of 1 over, that's 1 over n squared. I'm jumping. Sorry, guys. So this is 1 over n cubed times the summation as I goes to from 1 to n of 2I squared minus I. All right. Now, if we know what these summations are, so this is a limit as n goes to infinity of 1 over n cubed. Now, 2I squared, so we're going to have the 2 out here. The summation of I squared is n plus 1, times 2n plus 1 all over 6. Now it's going to be minus, okay, that 2 is there. We need to put up another bracket here. I is just n plus 1 divided by 2. All right, now comes just a little bit of algebra. Let's see what we get. This is the limit as it goes to infinity of 1 over n cubed of, sorry. All right, I'm going to mark this out and put it at 3 here. So if I multiply this through, let me change pen colors here. This is n squared plus n times 2n plus 1. So let me now multiply that term out. So this is 2n cubed plus n squared plus 2n squared plus n all over 3 minus, this one's easy, n squared plus n divided by 2. Now I need to find a common denominator. So let's multiply this whole thing by 2 over 2 to get 6, and this whole thing by 3 over 3 to get 6. Ooh, let me do that. So this is the limit as n goes to infinity of 1 over 6 n cubed, I'm tired of dealing with that, of 2n cubed, 2 times 2 is 4, sorry about that, 4n cubed plus 2n squared plus 4n squared, yes, I could have added those, I know, plus 2n minus 3n squared, minus 3. Oh my goodness gracious, let's collect terms. N cubed, so I don't have any, I only have 1 n cubed. All right, so this is the limit as n goes to infinity of 1 over 6 n cubed times, see I have 4n cubed. What about my squares? I have square, 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 6 minus 3, so this is minus 3n squared. And then my other ones, this is negative n. I'm running out of room, so this is a limit as n goes to infinity of, let's see, 4n cubed minus 3n squared minus n divided by 6n cubed. I know it's hard to read. So that's the limit as n goes to infinity of 2/3 minus 1 over 2n minus, and that's just n, 1/6 n squared, which is 2/3. I know it's a lot of work. Now, see if you can do this problem. Pause the video. When you're done, turn it back on. This is a definition of a Riemann sum. Let f be defined on the closed interval AB, and let this delta be the partition of AB given by, now A is going to equal x naught, so that's your left term, and that's less than x1, less than x2, dot, 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 and let xn be defined as B, where xi is the width of the I subinterval. If ci is any point in the I subinterval, then the summation from 1 to n of fci xi is called its Riemann sum for this partition. Okay, if it's regular, then we can write it this way. The regular partition is equal to delta x, which is b minus a over n. Now, I can rewrite this so that b minus a divided by the partition of n has got to be less than or equal to n. All right. See if you can do some homework.